Here's a few more ellipse examples focusing on connecting the geometry to the algebra. So we have an ellipse that's known to have vertices 0 plus or minus 8, so on the y-axis, and foci 0 plus or minus 6, also on the y-axis. We want the equation of the ellipse. So this would be useful if we want to design some reflector that reflects this focus, like 0 plus 6 to 0 minus 6, light coming out of one into another, and we want it. This gives us an idea of how long the whole thing is, and we want to put this into some sort of computer drawing program to design it for us. So we know it's going to be something like this. Notice that the vertices are symmetrical around the origin, the foci are symmetrical around the origin, so the center is the origin. In the next one, we'll do one where the center is not the origin, but we haven't shifted it yet. Okay. Now, one of the tricky things, it's kind of stupid that you have to worry about this, but just the terminology about like where you put the A and the B, it shouldn't matter that much what letters are, but the standard terminology is that the A is the semi-major axis, and that's going along the y-axis here. The vertices and the foci are along the long direction, and so for ellipses, we're going to go ahead and recognize that the letters should be B under X and, y, and A under Y. Okay, what do we know? Well, the vertices are 8 units away from the center, so we know A is 8, or in other words, this is going to be 64. A squared is going to be 64. Okay, so that's known. Okay, and then we also know the foci, and we want the equation for this guy. Okay, well, one of the crucial things that connects the ellipses, the vertices, the A and the B and the C. So, right, C is distance from center to focus. It's just the name for that crucial thing, the distance from the center of the focus. And the crucial thing that I talked about in another video is that A squared is B squared plus C squared. You can draw a little triangle to tell yourself that A squared equals B squared plus C squared. To figure out which one is which on this, for an ellipse, just remember that A is further away. That's the biggest of the three. It's further away than B from the center. That tells you the minor vertices on the other side. And it's certainly further than C because the foci are inside the ellipse. So that's a way to remember it, is that A has got to be bigger, so it's the one that's the sum of the other two. Okay, so we know A squared. We don't know B squared, but we know C squared, that's 36. Okay, oops. And so B squared is just the difference of those, that's 28. Now luckily, I mean, we could say B equals root 28, I guess I'll put it down, but in terms of actually writing down the equation, we just really need B squared. Whoops, I keep messing that up. Okay, so we're going to just take this equation, we can just cut and paste that down here. Oh, that's the answer, whoops, don't want to give it away. There we go. Okay. So there's our equation. No, oh, sorry, just kidding. Ha ha ha. There's our equation, okay? And so that's a fairly straightforward one where we're given the information and then we just need one crucial thing, which is they gave us C, they gave us A, we want to find B, and it's this crucial equation, which is really Pythagoras. So here's the picture we get if you're going to draw it. You can go ahead and draw the vertices just from the given information, draw the foci from the given information, and then if you actually want to draw the ellipse, which I would actually ask in a reasonable problem, that's where the root 28 comes in. This is B and that's minus B, and root 28 is between 5 and 6, and so you can see it right there. So you'd just go ahead and draw the two vertices, what I would often call the minor vertices, the other sides, and the focus. It'd be nice to plot in at least one other point, or like maybe 4 other points. Just pick like x equals 1 or 2 or something like that. Maybe x equals 2, or maybe x equals 3 would be good. Okay, and draw some points carefully using the algebra, and then you'd have enough for a good ellipse. Okay, so that's one. We haven't shifted it. I feel like that's a relatively straightforward problem. Okay, so now let's see. Here's another one. Here's an ellipse with a different center, so it's shifted now. And they give us the vertex, and it passes through a point. So this is really important. There's no assertion that there's any special point on the ellipse. It's not necessarily related to the vertices or the foci or anything. Okay, and in fact, we're going to try to find the foci. So we have the center is 2 minus 3. The vertex, notice, or just one of the vertices, is directly to the right of that guy. Aha, so that tells us our major axis is horizontal. So that helps with the nomenclature. Okay, so the general formula, when we're going to shift, guys, like this. Now, I'm going to put an A under the X because that really makes sense. We're back to something that is a horizontal major axis. Again, I don't feel like that should be a huge important thing, but we want to agree with the right nomenclature. Okay, and it's important to know where the foci are. They're going to be in the X direction. They're going to be horizontal from the center. Okay, okay, and we know this guy. That's 2, and ooh, that's a minus 3, so that's going to end up being plus 3, y plus 3 squared. That's just doing the shift. Anytime you take something that starts out with center 0, 0, which is our standard ellipse, and shift it, it's going to always be the same thing with h and k. Notice the contrast between this and the parabola. There's no center for a parabola. The home base for the parabola is the vertex. That's quite different here. The home base for an ellipse is the center. And so that's what we want to look at for the shifting. We don't look at this, so that's quite a bit different from the parabola case. Okay, what else do we know? We can see that the vertex is 5 units to the right. Okay, so they actually are giving us A again here. Okay, so I can write that as 5 squared, or I can just write it as 25. Okay, and we want to find B. But in this case, they don't give us C, they just give us a random point. That's okay though, because we can just plug that in and do some algebra. Somewhat similar to some problems we did with parabolas. Okay, so 6 and minus 2. Okay, so that's going to be, let me copy and paste that again. Okay, that's just going to be 1 here. Oh, goodness. And that's going to be 16. 4 squared is 16. Okay. And so 1 over b squared is 1 minus 16 over 25. We can do that. Ooh, that's kind of nice. It's 9 over 25. Happens to be a perfect square. No necessary reason it has to be nice like that. Okay, I just picked it to be nice. And so flip both sides, b squared. You could cross multiply if you want, but you can just take the reciprocal of both sides and square root. Remember, you don't need a plus or minus here, because by definition, b is a distance. It's a length, and it's 5/3. Okay, so now we can just go back up here and plug it in. Oops. I can delete that big space there. Okay, so x minus 2 squared, and this is the quantity 5/3 all squared. And if you want to square that out, you can. I'm actually going to change this back to 5 squared to exhibit A, to exhibit B, H, and K. It's all set. Okay, now if we want to graph that, okay, well, we've got various points we can plot. We've got, we know what the center is. Let me see if I can go down. We know what the center is, 2 minus 3. We know, oh yeah, we're going to find the foci too. We know 7 minus 3, and then 5 units to the left symmetrically. We could have done that right at the start. Minus 3, comma, minus 3. You can also go 5/3 up and down from the center. That gives you 2, comma, what? Minus 1 1/3, and 2, comma, minus 4 2/3. Okay, and that gets a start. We could also, of course, plot the point. I didn't mark it, I don't think. We could plot the point 6, comma, minus 2. Ooh, let's make sure that, yeah, it's looking like it's going through my 6 minus 2. Okay, so that gets us a start. Now, what about the focus? I've got some extra stuff here. Oh yeah, here it is. Okay, this is from when I was making sure the problem was working. Oh yeah. So again, c squared. So let's look at the fundamental equation. Let me put it. I just remember it as a squared equals b squared plus c squared. Very nice. And that's going to be a little bit different from the hyperbola case, which we'll do very soon. Again, to keep track of it, just make sure that the thing that's always the biggest is the thing that's the sum of the other two guys. And that's going to be true in the hyperbola case. It's just the letters will be shifted. Okay, so c is just the square root of a squared minus b squared. I plugged them in. I took out a common factor of 25 and then square rooted it and just did a little cleanup. And then I actually asked the computer, oh, how big is that? About 4.7, because that helped me plot it. It's really close to the vertices. When you've got an ellipse that's relatively long and skinny, a high eccentricity, the foci are going to be really quite close to the vertices. I am always a little surprised at how far you have to push the focus out to get it to be really significantly long and skinny. Okay, so that would be a good plot, and the way you'd plot that again would be the vertices, the minor vertices. You could plot that 6 minus 2 point because it's given to you. You could also reflect that across, so minus 2 minus 2, and you reflect it down here, what is that? Minus 2 minus 4, and 6 minus 4. That will give you 4 more points to plot carefully. And then the foci, and you've got a pretty good sketch. Okay.